All right, so linear is a straight line, and since linear, the exponent for the variable is a 1, you're going to see that addition pattern in the first degree. The quadratic always has an exponent of 2 because it's always x squared. No phones, please. We can see that we're going to see an addition pattern, but on the second degree, and I'll show you how to find this. Addition pattern in the second degree. And for exponentials, you're going to see a pattern of multiplication. So we've got 3 different types and 3 different patterns. All right, so we're going to do these by graphing first. So if you guys want, we're going to do 3 examples. If you guys want to go ahead and make 3 coordinate planes, and maybe, I'm going to say I don't foresee any of them going over 8. So I've got, this is a new version, and on the last one I can hit next page. Oh, no way, that's fantastic. You know, it's not as great as what I thought. This is a new version of the board, and so I thought it was going to be something better than what it was. All right, so for this first one, I'm going to give you a set of ordered pairs, and you are going to graph them. After I have those listed, you are going to graph them. Set, so we do the curly brackets. So we have a set of ordered pairs. So if you are, some of your directions today will say graph each set of points. Your assignment, if you are in here, it's on paper. I have graph paper. It's also on Kami. If you want to do it on Kami, I will accept it either way. But if you were to graph this, you're going to graph, and then you are going to decide what pattern it follows. Is it linear, quadratic, or is it exponential? So if you are given these points, we simply just have to plot those on the graph. So where do I graph for -3, 0? -3, 0. Where's it? Where?
-3. Right on the x-axis, -3.
All right, right on the x-axis at -3. So at -3, 0. Then -2, -1 would be left 2, down 1. -1, -2, left 2, or left 1, down 2. 0, -3. That'd be -3 on the y-axis. And then +1, -4. All right, what kind of pattern is that looking like?
Linear.
It's that looking like a line, a parabola, or an exponential function? I was like, it's a straight line. So whenever you see that, if you can draw the line, you don't have to, but then you would just say, this is linear. Because once you graphed it, they're going in a pattern of a straight line. Now, I want to show you, if this were listed as a table, how you would be able to tell. So if you made it into a table, I think it's a little bit easier to see. All right, I want you to take a look at the Y. Look at the Y's here. Do you see a pattern from one Y coordinate to the next? Do you see the pattern? What's happening each time? All right, this pattern from here to here is -1, correct? From there to there, that's -1. So do you see how these have the same pattern on the first time we look at it? That's what it means in the first degree. They're all going to have the same pattern right away in the table. Now on a quadratic, we'll see something a little bit different. I don't want to go too fast. I know graphing takes a little bit more time. But do you guys have any questions on that linear example? Do I need to go back? I realized I didn't ask if you guys were done. Everybody good? All right, so for the next example, we're going to do the same thing. If you graph those, I have 5 points there. We're only going, biggest number I see is 4. So if we were to graph those, go -2, +4, -1, +1, 0, 0, 1, 1, and 2, 4. All right, just by looking at that, what do you think that's looking like? All right, that's definitely a parabola, right? So is this linear, quadratic, or exponential? All right, this is quadratic. I think from graphs it's a lot easier to see. And one thing that you will notice on a quadratic, you'll see numbers, like on this one, do you see how the Y values decrease, but then it goes back to increasing? Quadratics are the only one that go down and then go back up. An exponential, you'll only see increasing or decreasing. But if you look at this in a table, I want you to recognize the patterns here. So there's definitely a pattern with these numbers. Now, is it a multiplication pattern at all? If you look at the Y's, there's no multiplication pattern that would make this up. So we're going to do, it is an addition pattern, but let's just think about this for a second. How do you get from 4 to 1? All right, it's a -3. Now, what about from 1 to 0? That's a minus 1. What about from 0 to 1? Plus 1. And how do you get from 1 to 4? Plus 3. So, do you see how on the linear one, those were all the same, right? These are not. But what if you do this, look at these numbers and see the pattern. How do you get from -3 to -1? Plus 2. How do you get from -1 to +1? Plus 2. How do you get from +1 to +3? Alright, so remember how I said the quadratics, there would be an addition pattern in the second degree? So the first time it didn't have a common pattern, but the second one, the second numbers do. That's what it means by the second degree having an addition pattern. And sometimes the points that are given don't give you a really good graph like this one did. Sometimes the graph might only give you like one side, and so you're like, ooh, it could be exponential, can't really tell, so we can test it this way. So with the quadratic, you will see that addition pattern in the second degree. And hopefully, if it's a good graph, you'll see that parabola. All right, are you guys ready to see an exponential example?
Yep.
All right, so for exponential, we are going to see a little bit of a change. So I see something like this. Obviously, we have a lot of positive numbers on the y. It's going to look a little bit more like this. Two, 4, 6, 8, 10, 12, 14, 16, 18. I'm going to count by 2s on my y. Just to make it a little easier. I think on a graph here, you're probably going to see this one a little bit better on a graph. So if I go to -1, positive 2/3, 0, 2, 1, 6, and 2, 18. Hopefully you can see there that we've got an exponential function. An exponential function, it'll kind of look like a quadratic, but like on this one, it's constantly increasing. There's not like that matching side that goes back up to keep you from seeing that. So this is an exponential function. So if you're told to graph, that's all you would have to do. Now, if you are asked to do something with like differences or ratios, that's where you're finding the pattern with the table. So if you have your x and y's in a table, do you guys see a pattern here? Look at your y's. How do you get from 2/3 to 2, from 2 to 6, and 6 to 18?
Multiply by 3.
Multiply by 3. Even if you don't know the fraction, maybe do everything for it besides the fraction and then see if it works out. But just to let you know, if you take 2/3 times 3, the 3's cancel and it's just 2. So on this one, the pattern here is times 3. It's not an addition pattern. So exponentials definitely stand out more because their pattern is totally different. So since it is a multiplication pattern, that automatically tells us that it's exponential. Not always. No. So don't think that just because you see a fraction, because sometimes the pattern might be plus a half, or it might be, you might see, so you can see fractions in those addition patterns. Now I will say I would probably check for exponential first, because you know the other two have addition patterns. This is the only one that has exponential. So I would honestly probably look for multiplication first, like say, do you see a multiplication pattern? And if you do, it's exponential. If you don't see a multiplication pattern, then you decide if it's linear or quadratic. So I'm actually going to do a couple examples from your homework. So if you guys want to go ahead and open up the assignment, and we'll do one of the tables. The top ones are all graphing. So we'll open this up and we're going to do either 9, 10, or 11 together. So if you look at your assignment, the top half is all graphing. So if you guys would like to borrow graphing paper, or you can add graphing paper to Cami if you guys would like to do your work on the computer. But then the bottom half, it says use differences or ratios. That's at differences means like an addition or subtraction pattern. Ratios are multiplication patterns. So that's just telling you to find the pattern. Differences in ratios just says find the pattern. So do you guys want to do 9, 10, or 11?
Let's do them all.
Nope. Pick one.
9. Nope. Yeah.
Sure.
Seems like the easiest.
All right, so let's pick 9. All right, so if we look at this, is it a multiplication pattern? From 12 to 11 to 8 to 3 to 4.
Nope.
Definitely not a multiplication pattern. So let's look at the differences. How do you get from negative 12 to negative 11? All right, that's add 1. All right, how do you get from negative 11 to negative 8? Plus 3. How do you get from negative 8 to negative 3? Plus 5. And how do you get from negative 3 to positive 4? Plus 7. All right, so we did not have a common pattern on the first degree, but what about the second degree? How do you get from 1 to 3? How do you get from 3 to 5? Plus 2. How do you get from 5 to 7?
Plus 2.
All right, so we had we found a pattern in the second degree. So is this linear, quadratic, or is it exponential?
It's quadratic.
All right, this one is quadratic. So on that would be the type of work I would expect there. I would like to see that you're working out the patterns, and then you're telling me the pattern that it fits. And so you are doing that on 12 and 13. I think it's easier to see it as a table than it is as a list of points. So you could throw those points into a table and answer those the same way. All right, do you guys have any questions before we get started?